Hi everybody. Sorry I can't be there this morning. My dog had to have surgery, and so I had to be around to make sure that he was okay, and then when I got the call that he was good to go, and then I'm going to come in. So hopefully I'll see you later today. First of all, today we're going to start talking about climate change. It's the last 2 days before we have our test on Thursday. You will get a study guide. Hopefully I will have that for you tomorrow morning. If not, definitely Tuesday morning, so that you have the most time to look over it as you can this week. I am going to include a little bit of information about climates and how the convection cycle worked and why the earth is warm in certain places and cooler in certain other places. So make sure that you remember that information, because that does play a part into the weather that we've been talking about and into why certain parts of the globe are heating up faster than others. And we're going to learn about which parts those are in the next 2 days. So first, as part of my class, we know that we come in silently. We start our do now silently. Hopefully we've done that for our wonderful substitute teacher, whoever that may be at this moment. And remember the classroom rules, that you're sitting in your assigned seats. You don't get up unless you ask, and you raise your hand if you have a question. And I'll just say this now: when we dismiss, we silently stand behind our desks, and we are dismissed when an entire side of the room or the entire classroom is silent. Make sure you remember that and you follow those expectations. You also have homework that's due today. Turn in the homework. If you have it in your locker, bring it in later by the end of the day and make sure it gets to me. So let's get started on the do now. Today's do now is prepping us for what we already know. We're going to tap into some things that we might have already known, or maybe we wonder about in terms of climate change. So my first question for you is, what do you already know about climate change? Either the causes or the effects, maybe some things you've heard, controversy, anything like that. So you guys should take 2 minutes as a class to discuss, what do you already know about climate change? Good. So now, what do you think will happen if climate change continues the way it is, or if it gets worse? What do you think those effects are going to be? What changes will we see even more than what we've already seen? Okay, finally, and next, if 97 people told you that one of the elevators in the community education building was not working right and might fall, but 3 people told you that it was fine, would you ride that elevator? And why, or why not? Please explain. And finally, thinking about those 97 people and the 3 people who told you it was okay to ride the elevator, what if one of those people were Mrs. Johnson or Miss Childs, if you weren't sure who Mrs. Johnson was yet? What if she told you that it was okay to ride the elevator? You know, thinking that she's a reputable source, she's the executive director of our school, would that change your mind? If you said it would change your mind, why would it change your mind? If you said it wouldn't change your mind, why wouldn't it change your mind? So I ask you these last 2 questions because the consensus on climate change is that 97% of all published studies that concern climate change agree that humans are causing climate change and that it is happening. Not that it will happen in the future, it is happening right now. Those 3% are often found to be paid research articles that are tied to either the oil industry or some kind of energy production where there's money involved. So they might be biased or have certain other agendas in their research when they're reporting that climate change is natural or that humans are causing it. In science, it's a natural thing for scientists to want to question each other and say, wait a second, how can you be so sure that it's people causing this? There have been natural fluctuations in the climate on Earth in the past, and we've studied this using lots of different lines of evidence. And we're going to look at a couple of those lines of evidence to show that, yes, it is actually humans causing this. And not only are we causing it, but we're causing it to happen faster than it's ever happened in the history of Earth. Okay, so coming up in this lecture, carbon dioxide in our atmosphere. What is it and what does it do? What is the evidence for climate change? And then you'll do your exit ticket. First, we're going to go through some vocabulary to get us grounded and make sure we understand what all these terms mean. The first is carbon dioxide. You hear this word a lot when you hear about climate change. Carbon dioxide is a molecule of gas that is a carbon and two oxygens, CO2, that is naturally occurring in our atmosphere. However, humans have artificially and excessively dumped tons and tons of CO2 into the atmosphere. And when I refer to carbon dioxide, I may call it carbon dioxide or I may call it CO2. CO2 is the same thing, that's just its atomic formula. And you should have learned this in physical science, that CO2 means carbon and two oxygens. The next word is greenhouse gas. A greenhouse gas is a gaseous molecule like carbon dioxide that traps heat in our atmosphere. That trapped heat is like a blanket. So these gases are like a blanket over the earth. And the more blankets and the more molecules that we put into our atmosphere, the more heat is trapped underneath of it and warms up our planet even more. Global climate change and global warming. What is the difference between those two terms? Well, global climate change refers to all of the changes that are occurring due to human activity. So due to those greenhouse gases, there's warming. There's some droughts that will occur. There's some flooding that will occur. The ocean will get warmer. It will also become more acidic. Some severe thunderstorms or hurricanes will become even more severe. Lots of wildlife will not survive because they can't adapt soon enough to be able to keep up with these changes. Global warming is the actual warming of the earth. So that's one symptom of the many changes that are going to occur. So that is just one piece of the larger idea of global climate change. Because some climates will become more rainy or more flooded and some will become drier. So it's not just one thing that's going to occur. It's not just that everything's going to get warmer. All of these other symptoms are going to occur. And so here I'll put the definitions for you so you may copy them down. Okay, and here's your vocabulary list for you to copy down in your notes. Please take 5 minutes to make sure you get all of these terms and their definitions. Okay, let's start with carbon dioxide. Carbon dioxide is, like I said, a blanket around the earth. As the sunlight passes through the atmosphere and warms the earth's surface, the heat is radiated back towards space. And you can see that here with these rays of sunlight bouncing off the surface. These two arrows get stuck, and then they bounce back into the atmosphere and kind of keep bouncing around as heat, warming us up. These two will escape back into space. And as we add more layers of this blanket, more CO2 to the atmosphere, less of these arrows are going to make it back out to space, releasing some of that heat. We live in a greenhouse. I'll read this out loud. Please follow along. Life on Earth depends on energy coming from the sun. About half of the light reaching Earth's surface passes through the air and clouds to the surface, where it is absorbed and then radiated upward in the form of infrared heat. About 90% of this heat is then absorbed by the greenhouse gases and radiated back toward the surface, which is warmed to a life-supporting average of 59 degrees Fahrenheit, or 15 degrees Celsius. So what this is saying is that this greenhouse effect is actually crucial to us surviving on the earth. It's not really a bad thing that it's occurring. It's just that we're adding so many blankets that we're trapping too much heat. We're trapping much more than is naturally supposed to be trapped. So what does carbon dioxide look like in the past? So the way we measure concentrations is that we take a sample of the air and measure how much carbon dioxide is there versus all of the other molecules. And so if we take 1,000,000 molecules of gas, how many of those molecules are going to be carbon dioxide? And that's how we measure the concentration historically. And so if we look here at our y-axis, we have carbon dioxide level in parts per million. So how many molecules per 1,000,000 molecules would be carbon dioxide? So it looks like here we're going back 400,000 years. 400,000 years. Just think about how much time that is. This one class period probably feels like 400,000 years sometimes. However, this is a very, very long time. It's longer than human civilization has even been around. So think about that. Even before humans became farmers and living in houses and stuff, before we became anything social, we were able to measure that far back to get the CO2 levels. And so let's look at our x-axis. So 400,000, then 350,000, then 300, then 250. What is the scale that we're measuring here on this graph? It is by 50,000 years. So every 50,000 years, we have some data in between, and those are our major categories of time. On the left axis, we start here at 160, 180, 200. So we're going by 20 parts per million on the y-axis. So if we start here back at 400,000 years ago and go all the way up to modern day, 0, we see that the CO2 concentration has never reached above this dotted line. This dotted line is at around 280 parts per million. So the carbon dioxide concentration has never reached above 280 parts per million. So how did scientists measure this CO2 from hundreds of thousands of years ago? Well, one way that they can measure this is using ice cores. It's kind of like taking a plug of the ice. Imagine taking a straw and sticking it down into ice cream, putting your finger over it and pulling it up. And then you have this long tube of ice cream inside of your straw. It's kind of the same deal. They're going to drill down into the ice with this very long straw or pipe, get that ice core and pull it back up. And then so every year there's ice added to this ice sheet. And so we have pretty much a yearly record of what the ice looked like, and inside the ice are tiny little air bubbles that trapped the atmosphere at that point in time. It's kind of like a picture or a snapshot of that atmosphere at that time in Earth's history. So the farthest back that they've gone is probably, I think, longer than 400,000 years, but for our purposes, 400,000 years is a pretty good chunk of time. So they went back that far, looked at the little bubbles and measured the concentration, because even in these little bubbles, there's way more than 1,000,000 molecules of atmosphere. So they were able to calculate the concentration of carbon dioxide all the way back then. So they took these little bubbles for every single year, or maybe every 10 years in this ice core, and were able to calculate and then have this nice information about what the atmosphere looked like in terms of how much carbon dioxide there was in history. And as we said, back down into our notes, CO2 has never reached above 280 parts per million in the last 400 years. I'm sorry, 400,000 years. So then if we come up to the year 0, right around here, and I will tell you this is the year 1850, right around 1850, there's a huge sharp spike of carbon dioxide. What is going on there? We don't see this in any other part of the graph. Maybe right here there's a pretty sharp spike around 120,000 years ago. But this still slopes over about 10,000 years. This line goes up over 200 years. It's never increased past 280 parts per million, and it's never increased this fast before. So this is alarming, especially to scientists who are studying the climate of the past. This is alarming. Today, the sudden increase in CO2 happened around the year 1850 when the Industrial Revolution happened. The Industrial Revolution was when people started making factories. They started using machines to build things and to do work for them. We learned how simple machines can make work easier for people to use less energy. However, when they started using these machines, they used coal to fuel them. This coal burns very dirty. It pollutes the air with not just CO2, but it pollutes the air with lots of different pollutants that we're going to learn more about tomorrow. This pollution and this way of burning coal polluted the air and started off our insatiable need to burn fossil fuels. Once we learned that those harness so much energy, it was kind of downhill from there. Or in the case of CO2, uphill. So during this Industrial Revolution, we started dumping all of these chemicals into the air. And so by today, carbon dioxide levels have risen to 406 parts per million. And it continues to increase as we burn fossil fuels and release other greenhouse gases. At this point, the class is going to watch a video of how CO2 is circulating around the Earth. I want you to answer which 3 locations release the most carbon dioxide. Where did most of the CO2 end up after it was released and circulated? After that, you're going to watch a video of Bill Nye explaining climate change. We've seen Bill Nye from the 90s explaining all these science concepts to us and how, we can relate to them in different ways in a fun, entertaining show. However, Bill Nye today is a science advocate, and he's an advocate for taking climate change seriously, especially in politics when not many politicians are taking it seriously. And again, it kind of comes back to that money, the way the energy, the oil, and the coal companies don't want to acknowledge that climate change is real and it's actually caused by them, because that's a liability. They could be sued or owed a lot of money because it's pretty much coming back to their activities. So Bill Nye explains the importance of climate change. At the end of class, after you watch Bill Nye, you're going to do research on 2 of the pieces of evidence for climate change. You're going to go to the website climate.nasa.gov. You're going to choose one of the above pieces of evidence or effects of climate change and explain it in more detail. Tell us what's happening. Include how it has changed over time and what is predicted for the future. Why should we be worried about it? If you choose a second piece of evidence, you'll get extra credit. This is a very important time to get extra credit because our semester is coming to an end, our marking period. Get the extra credit while you can. First period's homework goes in the red bin in the cart on the side of the room by my desk. Second period's homework goes in the next color bin down, it's either green or blue. And third period goes in the third color, which is either green or. Second period goes in the second bin down, which should be orange. And third period should be the green bin. So please put those homeworks in the cart for me in that order. So that I have them when I come into school today. These are your evidences for climate change. You're going to find them right on that website. Warming the atmosphere, warming oceans, shrinking ice sheets on continents such as Antarctica or Greenland, glacial retreat, decreased snow cover, sea level rise, shrinking Arctic sea ice, extreme events, and ocean acidification. I hope you guys have a great class. Please make sure that you use the laptops responsibly and that you are not getting out of your seats, calling out, being disrespectful, because I will hear about it and there will be consequences.